Okay, for this problem, here, I have a problem. O sea, like, I am sorry, like, this I shouldn't have, like, erased it. So here they are asking you for what sampling technique you have used, or you use for this problem. And there is a list of the sampling methods, and you need to memorize that list. For this exam, I won't ask you to do it. When we go deeper into statistics, I will teach you the sampling methods. It's a very easy list. O sea, you only need to remember what sampling method you need to use, and there is 100% probability that a question such like what sampling method you would use for this problem will appear in the exam, and there is 100, o sea, like in the IB exam of May 2027, and there is a 100% probability that it will be only 1 mark. O sea, it is a very subtle, it's a very easy way of gaining a mark, but let us not focus on that. Okay, so I have like this diagram, no? Remember that whenever I have a bifurcation in a tree diagram, these things need to add up to 100. So it is very easy that this would be 95%, this would be 1%. And now if you read the problem, here it says that two people who don't have the disease, o sea, if I don't have the disease, I test positive, no? O sea, this is 0. O sea, this is 2%. So this is 98%. Great. Okay, once that we have completed the diagram, let us go through the problems, no? What is the probability that our patient will not have the disease and test positive? So, what is the probability that a patient does not have the disease and then that the probability tests positive? O sea, I need to multiply those two numbers. So I need to do 0.95 times 0.2, which is 0.019. O sea, like, it will have a 1.9% of probability that he's not diseased and will test positive. What is the probability that I will test negative? O sea, then I need to go. There are two branches. One branch that is this, o sea, actually having the disease and testing negative, and don't having the disease and testing negative. So, one branch is not having the disease. No, sorry, having the disease and testing negative. O sea, this part is not having the disease and testing negative, plus the 95% is what? Sorry, having the disease and testing negative, or not having the disease and testing uh, negative. Put this into the calculator. That is 0.932. O sea, rounded to three significant figures. So that is 93.2%. Okay, now what is the probability? What is the probability that a patient has the disease given that they tested negative? Okay, so I already know here I am asking for the probability that a patient has the disease given that the test is negative. So if you remember the Bayes theorem formula that I have here, where do I have it? I have it here. Bayes, maybe given, no, conditional. Aquí está, conditional. So the conditional probability is the probability of the intersection divided by the probability of o sea, of B, no? So that would be the probability that I have the disease, o sea, has disease, I and este test negative divided by the probability of testing negative. What is the probability of having the disease and testing negative? The probability of having the disease, o sea, I have the disease and I test negative. So that is zero point 0.5, o sea, this is 0.05 times 0.01 divided by what we calculated in here, no? So the probability to test negative is this one, no? Divided by 0.932. And you do that calculation, and that is 0.000536. O sea, that is less than 0.05% of probability, ¿no? Bueno, that is 0.0536% of probability. Um, the medical center finds the actual number of positive results in the sample, and their sample is different than predicted by the tree diagram. So why is this probability not exactly the number that you receive, o sea, when doing it, o sea, in like real life? So a way of knowing, o sea, a reason, and it has to do with the sampling, is that maybe the sample is not representative. O sea, so maybe the sample is not representative of the population. So when we talk about sampling methods, this will be way more clear. I wouldn't ask something about sampling techniques right now, no? Okay, to do the Venn diagram, you need to draw like a universe set, like the rectangle with three little balls inside, label D, M, and N as the sets, no? Okay, so we're going to start with the most inner part of the information. So read it, and you will find that we have 9 patients that were seen by a doctor, a nurse, and have had medical tests, no? Then we have, for example, 2 patients, o sea, try to pick the information that has, o sea, like the data that has most information, no? For example, 2 patients were seen by a doctor without seeing a nurse and without receiving any medical tests. O sea, 2 patients have been seen by a doctor without being in the other sets. Um, then we have 11 patients that were seen by a nurse and had a medical test, but they did not see a doctor. That's an 11. 18 patients that had medical tests and were seen by a doctor, but they did not have a medical test. No, okay. 18 that they were not seen by a nurse, no? Then we have that 30 patients were seen by a doctor. So if 30 patients were seen by a doctor, that means that in this ball, I should have 30. No, it should add up to 30. So this is 2 plus 18, 20, plus 9, 29. So I need 1 in here, that would be 30. 45 were seen by a nurse. So that means that adding all of this, so this is 24. No, that is 21 plus 24, 45. Now I have 45 in here. And 78 took a medical test. So this is 20, 38. So this is 40. And that would be 3 marks. And to find the total number of patients who visiting the center, you just need to add up all the numbers. So you need to do 2 plus 18 plus 9 plus 1 plus 40. plus 11 plus 24, and that is, o sea, add all the numbers, and that is 105.